I'm really excited to have joining us today, Gabriel Steinhardt. He's the founder of Blackblot and the recognized international product management expert, author, and lecturer. He has published 2 books on product management and 1 on product pricing, and his Blackblot Product Manager's Toolkit aims to provide a practical, consistent, and holistic approach to product management and helps both PMs and organizations develop clear and consistent practices. We're really excited to have him joining us today, and welcome, Gabriel.
Thank you all for joining in today, and it's a pleasure for me to be here with you. My name is Gabriel Steinhardt, and this presentation is titled Algorithmic Feature Prioritization. Following this session, you will be able to describe the importance and implications of product feature prioritization, realize the pros and cons of scale-based prioritization and scoring methods. Sometimes they're also called sorting methods, and apply Blackblot's Boolean-based algorithmic product feature prioritization model. So before we start sorting product features, let's understand what are product features. So I think everybody knows what Gore Tex is. Gore Tex is a waterproof, breathable fabric invented in 1969 by Bill and Bob Gore, a father and son combination. They're both chemical engineers, and they issued a strong patent on the Gore Tex fabric, and the Gore family became billionaires. Now, Gore Tex is a technology. It's a layered fabric that repels liquid water trying to come in from one side while allowing water vapor, something like sweat, to pass through from the other side. It is a fabric that's designed to be lightweight, waterproof, and breathable. Now, what we see over here is a Nike shoe constructed with Gore Tex fabric. You can see the red circle over here that indicates that this shoe was constructed with Gore Tex. And therefore, this shoe has the feature of being waterproof and breathable. Now, in order for us to fully understand what it means, a product feature, then let's go to the PMTK glossary and see what it means. A product feature is a product's functional capability that satisfies a specific customer need. And therefore, the capability which the product has is its feature. And a product feature set is the sum of all product features that represents the reality of what a product can do, which is the sum of all the capabilities that the product has. Now, technology is the enabler of a feature. Technology creates and enables a feature. So here's some simplified examples. The Swiss Army knife has a feature of cutting, and the technology used is a metal blade. The Nike shoe has the feature, the capability of being water resistant. Technology is Gore Tex. Navigation software has the ability to present different routes and allow us to plan and choose the route that we want to take in order to reach our destination. GPS is the technology. MS Outlook, which I know everybody knows, it's a messaging email application made by Microsoft. The feature is messaging, and all those protocols, SMTP, IMAP, and so forth, are the technology which enables the feature of messaging. So here we have is a simplified product feature set. And one feature is that it's obviously waterproof and breathable. And let's assume that there's some kind of construction in the heel or the sole that makes it shock absorbing. So it's shock absorbing, and the materials are sturdy, so it is wear resistance. If we take another example of a feature set, then navigation software has the ability to help us with route planning, suggest several routes and you choose one. Live tracking, which means that other people can follow us along the path where we're progressing towards our destination. And weather forecasting information, so we can make a more informed decision on a particular route or path. Now, the question is, why do we need to select and prioritize these product features? Why can't we have it all? Or in another sense, what is the problem of having it all? Really, there's a question over here what is the importance and what are the implications of doing product feature prioritization? So first, we need to realize, of course, that the product is a solution to the market problem. The product, by merit of its feature set, is the solution to the market problem, which obviously customers want to solve. So this obviously means that any given product feature set have a direct bearing on the product's chances of achieving marketplace success. So selecting the right feature set is important and can lead to having the right solution to the market problem. Another thing is that the selected feature set immediately impacts the development effort and the subsequent marketing and operational activities. And that every feature has to be developed, tested, fixed, documented, marketed, sold, supported, and then possibly terminated. So there's immense implications for every feature in terms of the effort, the work, the cost, and the schedule. This means that we need to optimize the feature set. It is critical to select the best features and optimize the feature set to fit the market needs to get that optimal solution, subject to the budget and the scheduling constraints. Now, in order to do that, we need to engage in something which is called the product feature selection process. And this product feature selection process is comprised of 3 stages or phases. So the first one is to identify redundant, extra, superfluous, or missing features. This is done through something called traceability, and it's out of scope for this particular presentation, so we're going to skip it. Then once we have the feature set, we can arrange those features in groups and to release the product in stages into the market. A more accurate way of describing it is that we're going to release the functionality into the market in steps progressively. So this is, again, is out of scope for this presentation, how to do roadmaps and versions. But lastly, we're going to analyze and prioritize the features, and sometimes we're going to move features between versions or decide, depending on how we launch products, which features are going to come first, are going to be included. So let's discuss the product feature prioritization process, or what's happening now in the market. The most commonly used and arguably the most biased and ineffectual way of prioritizing product features is what's called a simple unstructured debate. Usually have the product stakeholders, mostly people from product management and product development, perhaps people from sales, maybe 1 or 2 executives. They all convene for a series of periodical prioritization meetings. And in those meetings, they argue their feature preferences, their personal feature preferences, and they negotiate feature prioritizations. The unstructured debates are notoriously lengthy without a lot of progress being made. Often there's 1 or 2 meetings near some kind of a critical milestone, like a product launch or some kind of release to the customer, whatever it is, in which everybody convenes to these hastily enforced meetings, and very quickly resolutions are made and prioritizations are decided upon. Sometimes these meetings can be very long and rife with a lot of conflict and internal bickering. The bickering could be around areas of ownership, final decision-making, which prioritization criteria to use, which scores to assign to each criteria. So what they do is they move to a more structured debate. This is called a semi-structured debate, by introducing into discussion some kind of a market-related consideration, some kind of a deadline, technological trends that you need to match, a competitor has launched a product, economic, political, it could be something like that. And they focus on it. But it's all very vague and subjective, and it doesn't really help you do prioritization on a larger scale. So in order to bring more structure into the discussion, they take a look at something which is called ranking and scoring methods. And sometimes these are called, again, sorting methods. So here's some of the more popular ranking and scoring methods: Moscow, rice, ice, weighted, short, job first, and so forth. The thing about these scoring and ranking methods is that there's many of them. It's really going to Antarctica, and everywhere you turn, there's a penguin standing there. There's actually, somebody did a survey and they found that at the moment, more than 170 different product feature scoring and ranking methods available to choose from. So everywhere you go, there's a new one. Now, in aggregate, talking about these 170 different types of scoring and ranking methods, there are challenges in using them. And some of them are too abstract, these things called impact and reach. You have to define things in a more accurate way in order to use them. And that is a bit of a challenge. Some of the meetings are centered on trying to explain what is impact and what is reach and how to quantify it and how to score it. Difficult to reach agreement on many things which are vague. It's time consuming to try to parse different types of criteria. These methods don't work well with ad hoc requests. For example, an executive comes and says, I want to add this feature, or a customer says, I'll pay you to add this feature. A lot of the criteria and these methods are very high level. They're debatable, subjective, and you often don't have enough information. Many of these ranking methods use a scale, and the significant downside of using scale-based prioritization is that the participants quickly gravitate to repeatedly selecting the intermediate values of the scale. So if you give them 1 to 10, they will focus on a 7. If you give them 1 to 5, they will gravitate towards the 3. If you use a qualitative scale, then they will gravitate to the intermediate value. If you give them high, medium, low, they're going to go for the medium predominantly most of the time. Now, some of these ranking and scoring methods use something called weighted scores. Weighted scoring grants certain variables more weight, more impact in the calculation of a final score that determines the ranking. For example, let's say you have 2 variables. One of them is weighted at 70% and the other one is 30%. That means that the final score is going to take the weighted at 70% variable, and it will have more impact in the final score. So the problem with weighted scoring is that this method is easily open to manipulations to achieve the desired results. Now, all these factors combined, and the lack of a solid feature selection process or a structured prioritization method can lead us to something which is called scope creep. While we're discussing and debating and having those meetings, the product feature set grows uncontrollably and it just gets bloated and bloated while we're trying to prioritize things. And because we're unable to prioritize, we're unable to disqualify anything, and the feature set just grows. So obviously we need a better way of doing product feature prioritization. And the way that I developed and I suggest, and with the help of some people on my team, is what's called a Boolean-based algorithmic approach. Now that's some fancy words for something very simple. So let's explain this. Boolean-based means data with only 2 possible values. True, false, yes, no, high, low, 0, 1, 2 options of any kind. So if you're presented with questions that are Boolean-based, that means that the model forces you to make an unequivocal decision. Either you turn left or you turn right. There's no maybe, or let's stay put at the moment. So that's one thing. An algorithm is a set of instructions with a finite number of steps to accomplish a task. So the premise over here, if we're going to apply an algorithmic model to product feature prioritization, is that we're going to be able to consistently and uniformly perform product feature prioritization in a finite number of steps. And this is the Blackblot algorithmic model for product feature prioritization. So the Blackblot model is built on qualifying a product feature using 4 core parameters that could be supplemented with additional parameters if so needed. Let's take a look at these 4 core parameters. So the first one is called dependency, which is the measure of how dependent are other features on the existence of this feature. And again, it's a Boolean, high or low. There is no maybe or medium over here. The second parameter is fundamental. This product will not work properly without this feature from a technical perspective, yes or no. So fundamental means that all the features in the product that are fundamental are like the backbone. You must have them from a technical perspective so that the product can function. Differentiator is a feature that is a key differentiator relative to competing products, yes or no. Now, in the model that we're going to see at the moment, the differentiator parameter is held for reference purposes and possibly future inclusion into the calculation formula. But it's very easy to expand them all. And it's here that the differentiator model is included just to demonstrate how easy it is to expand the model. So the last fourth parameter is called importance. And this is product manager's subjective measure of importance of this feature from any perspective, from product planning, product marketing, product management. It's we believe this is important, yes or no, high or low. So this is essentially a table that contains our decisions. What we did over here is we assigned values to each product feature according to the 4 core parameters. This is data. Now everything is calculated automatically for us. So there's an interim support variable that is calculated automatically as high for all the features which are fundamental, which means that they got to be in the product for the product to function from a technical perspective, or that you got to have them high dependency because other features rely on the existence of this feature. Okay, so this is the interim variable, which is called urgency. Now we have the final priority variable, the prioritization level, which is calculated automatically for importance and urgency combination. So we know what urgency is. Importance is our subjective assessment of if this feature should be included or not, if it's a high importance or low importance. And here are the prioritizations. P1 is the most highly prioritized, P4 is the low priority. And you can see here how the combinations are structured. High importance and high urgency will earn it a P1, that is high priority. So at this stage, we have a prioritized product feature set. And let me recap this. After we complete attribution of values to the 4 core parameters for each feature, the feature matrix is essentially ready and presents a list of prioritized features. And at this point, we can start grouping the features to create distinct versions or roadmaps, whatever we want. Now, this table itself is essentially simplified. It's an oversimplification. Let's look at the complete table with all the various options because there's a lot more over there that can be done. So what I'm going to do now is I'm going to stop the PowerPoint. I'm going to transition to different types of screen sharing, and I will load the Excel file, which is the feature matrix. Okay, so let's take a look over here. This is the feature matrix, and what we see over here are tabs. And at the bottom here, there's the left tab, which is just the title. There are settings, which are the different variables and the different labels that they have. And this is just better programming, so you can change the labels or add, do whatever you want over here. And so there's some instructions here in the background which show the different combinations which create the different priority levels and some explanations. So let's go ahead and take a look at the feature matrix. Here we have the 3 features of that Nike shoe, just for reference. These 2 columns are descriptive columns, which at the moment are not used in the calculations, but they're there for any debates, or perhaps if you want to, you can later include them in the formula. Or OSRC, outsourceable, means that this feature can be handed out to contract development, yes, no, or in-house contractor. And T-risk is the level of technical risk associated with developing this feature. These are for discussions and debates, but we can add them into the formula. Now, here are the 4 core parameters: dependency, how dependent are the features on this feature; fundamental, the product will not work properly without this feature from a technical perspective; differentiator, and importance is our subjective measure of importance of this feature. Once we complete all of these blue 4 core parameters, urgency is calculated automatically as high for all features which are fundamental or have a high dependency. And the prioritization is also calculated automatically. So that was rather quick. Now, sometimes what happens is that you need to override the prioritization level that was calculated automatically because an exec says we want this feature in, or a customer pays you money in order to include this feature. So you can come over here and select an override. Now, the system is built in such a way that you can only promote a feature, which means if a feature was calculated automatically to have a low priority, you can elevate it and you can raise it to a higher priority. But if the system calculated a high priority, you cannot demote it, you cannot lower that prioritization. Now, obviously, this is my view of things, and that's how the system was built. So in any case, what we have over here is a column called in this version. And these are the features that we're going to start working on. And at the moment, you can see that the formula over here selects the following features: everything that is P1, anything that is P2 and fundamental, or the override is P1. So now we have a list of features here that we can start working on. We can decide if it's a version, we can decide that this is the priorities that we're going to follow, and so forth. This is really a wish list in a sense. And we have not considered things such as the cost and duration of developing a feature. Some features take more time to develop and some features take more money to develop. And you need to balance that out. So what we have over here is two more parameters to consider: the cost, estimated relative cost to develop this feature, high or low, and duration, the estimated relative time required to develop this feature, high and low. And through combinations of cost and duration, we have four combinations, we can reprioritize the original, let's call it wish list, subject to and considering the cost and duration of those features. So now we have a reprioritized list, and we can also do an override over that one. And you get, in this version, a list of features which are essentially our wish list and have been reconsidered according to the cost and duration. Now, all the formulas are open and everything can be changed, but this is the basic idea behind the feature matrix. There's a lot of more things that can be done over here. You can extract some statistics, how many features in this version are differentiators, how much are P1s and P2s, how much are fundamentals, how much, whatever you want. There's a lot of statistics that can be done over here, and that could help in creating versions or in prioritization. So let me close this and revert back to the PowerPoint presentation. So let me continue. We're going to use this product as a metaphor for some products that I've seen actually recently. I'm sure that you've seen software that looks like this. This is the Wenger Giant Swiss Army knife. It's actually been discontinued now. It weighs 1.5 kilos. It's got 130 different types of implements. It's really a novelty in this particular sense. It comes in this black wood box. There's unboxing videos on YouTube of people using this and opening it. This used to cost $1,500. Now that it's been discontinued, I think I saw on eBay somebody selling it for $8,000. So that's a good investment if you have one of these. There are three types of scenarios that cause software or other products to have so many features like this. The first one is called technology-driven. And in a technology-driven scenario, the engineers are in control of the feature set. They believe that more features will add more value. So they just add more features and add more budget and ask for more time and postpone the release date. That often happens in certain technology-driven companies. Another scenario is that we just don't know how to do prioritization. Everything is important, or we constantly argue and bicker and about who's going to do the prioritization and what prioritization criteria. And while we're talking, the feature set just grows and everything is important. Another reason that we have these kind of products is something called feature poker. Now, poker is an American card game. Often you see it in Wild West movies, and one guy says, "I will match your $5 and I'll raise you $2," and then the other guy matches and raises. Feature poker is when we release a product into the market, the competition copies our feature set and adds more features. Then we copy their feature set and add more features. And this is how, through several cycles, we get these products. You see, really, what the customers want is a product with an optimized, prioritized feature set, exactly what is needed for the right user and the right task. So let's conclude now with the summary. I think some people think that product feature prioritization can be a daunting and exhausting task, and some people don't like it because of the endless meetings and the ambiguity. But with the right tool, such as an algorithmic model, this or anything else that you can come up with, this critical activity can be accomplished far more easily and faster than ever before. So if anybody wants to communicate after this session and send questions or comments, then you can do it through the Blackblot website, or you can reach me on LinkedIn. And at this point, I want to thank Scott Baldwin for inviting me over. I want to thank you all for listening in to this presentation. I hope you've gained some new insights and new ways of thinking about product feature prioritization. And I hope it will help you in your career and doing your work. So at this stage, I think we're into the Q&A. I will stop the sharing now. And if anybody has any questions, I'll be happy to answer them.